Let's talk about a bridge. It's not in the river or in an ocean. It's on the galvanic cell or the voltaic cell. Yes, I'm talking about salt bridge. So why this is important? Because in my previous video I explained the mechanism and the structure of Daniell cell or voltaic cell, and in this video I'm going to explain what are the uses of salt bridge and why it is used. You must know about the structure. You must know that electrochemical cells, two types, electrolytic cell and galvanic cell. So the salt bridge is used in the galvanic cell. Why? When you know that zinc is working as anode here and copper is working as cathode. So we know it. So this is working as anode and this is working as cathode. I'm assuming that you know about the Daniell cell previously, because when somebody is actually clarify about the structure and the function of Daniell cell correctly, and then we can understand actually the use of salt bridge. You know that this is zinc and this is copper, and zinc is more reactive than copper, so zinc is releasing electron. So when electron is moving from zinc to copper, this is the movement, and we know that this is electricity, because electricity is nothing but the flow of electron. So zinc is releasing electron and copper 2 plus was accepting the electrons. You know it that previously this is the equations or the cell notations of the Daniell cell. So it was the cell notations of the Daniell cell. So this reaction is known as anode half, oxidation half reaction, and this is reduction half reaction. So shortly we can say that oxidation half reaction and reduction half reaction, and that is why it's combination of redox. And why these things is going on? When zinc is releasing electron, then zinc 2 plus ion, like from there zinc 2 plus ion is released. Zinc 2 plus, zinc 2 plus, zinc 2 plus and zinc 2 plus. So in that zinc sulfate solution, when the Daniell cell is working, after some time the abundance of zinc 2 plus ion will be in this solution. Okay, because zinc is releasing electron and it is no longer in the zinc metal, so it is releasing into the solutions as a dissolved ion, so it is actually roaming here as a zinc 2 plus ion. In the other side, copper 2 plus is accepting that electron and becomes copper as a solid. So here copper atoms will be added. So here copper atoms will be added, and then the sulfate ion will be more in these solutions. So there will be abundance of sulfate ions in the copper sulfur solution, and the abundance of zinc 2 plus ion will be here in this solution. So why it will use the salt bridge? Because after some time, when the abundance or increase of zinc 2 plus ion in zinc sulfate solution and copper sulfate solutions in the other side, then it stops the flow of electron. So to maintain the charge neutrality into these both solutions and maintaining the electricity, we need to use something that will actually minimize these ions increment in both solutions, and this is salt bridge. And this salt bridge is made up with another chemical components like agar-agar, and then it is made up like a U-shaped and actually submerged into the both solutions. And then what's going on? Suppose this is potassium chloride, but it can be sodium chloride also. So when potassium chloride is used, we know that it is cation and anion. It can divide into two different ions. So when zinc 2 plus is getting increased in these solutions, then zinc 2 plus in aqueous solutions will accept chloride, and then it will produce zinc chloride salt. And on the other hand, that sulfate will use potassium and it will produce potassium sulfate. So now you think what's going on. I mean, when you studied about galvanic cell, you know that zinc is releasing electron, and that electron is moving through the wire, and the copper 2 plus ion is accepting that electrons. So here in cathode, the reductions half reaction is going on. In anode, oxidation half reaction is going on. And that level, this sulfate increment is going on here in this solution, and zinc 2 plus will be more here. So zinc metal will be shrink and the copper will be like this. So this zinc 2 plus will add with chloride ion, and then they will produce zinc chloride, and this potassium will add it with sulfate. So what's going on? So the chloride is coming in this direction and the potassium is going in that direction. So the salt breeze, the function of salt breeze is, we can say simply in one line, that the function of salt bridge is, number one, charge neutrality. It's very important. Charge neutrality in the both solutions. So the charge neutrality is maintained, and number two is maintaining the electricity or the electron flow, that is electricity, as because we know electricity is nothing but the flow of electron. So you know that why salt bridge is used, potassium chloride or even sodium chloride, whatever, this chloride which is anion will be attracted to the positive ions, here especially zinc 2 plus. So zinc 2 plus will add chloride to form zinc chloride, and this sulfate, thus increasing the sulfate, will add the cation and will produce potassium sulfate in the other solutions. So that is why when more zinc ions is releasing from these solution, they will form zinc sulfate, and the other side it will form potassium sulfate. If it is sodium chloride, then it will form sodium sulfate. So that is why the salt bridge is used. So it's used mainly for the charge neutrality in the both solutions and maintaining the electron flow in the cell, as it is an electrochemical cell. So I hope you understand a very short class about salt bridge, and I hope you have seen my previous video about the Daniell cell and the galvanic cell. So this is the short descriptions about the electrochemical cells, and I'm coming up with another video with the dry cell, the functions of dry cell and how the reactions is going on with the structure of it. So take care, see you in the next class, stay well, bye.